Okay. So give heading waves. Chapter 14, right? Chapter 14, waves. In the new textbook, it is 14. You have only 14 chapters. So, right. What is basically a wave? Can you tell me? What is basically a wave? Huh? What? Only that is a wave. Flow. How?
No, it has like a ripple effect.
Ripple effect. What is ripple effect?
Like, yeah.
Ripple. Waves. Waves. Okay. When you drop a stone on water, you will see ripple. Okay. So, what is actually getting transferred in a wave? Energy is transferred in a wave. Okay. See, just imagine there is a stretched string. A string is attached to this wall, and I'm stretching the string. When I strike this end, what is actually happening? The vibration. It's a type of energy. That energy is getting transferred from this point to this point. And after reaching this point, what will happen? It will get reflected. The wave will get reflected back. You can see vibrations. How is this vibrations produced? Actually, the wave is going, hitting this wall, and after that, it is getting reflected. So, reflection of waves you will study, superposition of waves you will study. There are so many terms which associated with waves. So, first you write waves. Waves are the method of transfer of energy. Waves are the method of transfer of energy. Waves are the method of transfer of energy. Waves are the method of transfer of energy from one part of a medium
From one part of medium. One part.
from one part of a medium to another, from one part of a medium to another without actual flow of matter. Transfer of energy from one part of a medium to another without actual flow of matter. Without actual flow of matter. Waves are the method of transfer of energy from one part of a medium to another without actual flow of matter. So you have a stretched string. You striking the string. The vibration is getting transferred. But is that this part of the string, is it moving? No. The string is not moving. Only the vibration is getting transferred. Okay, so energy is getting transferred without the actual movement of matter. How is the sound wave getting how is sound wave traveling? Through air. Like this. Then how? How sound wave is traveling?
Air particles, like when it's like yeah, they compress and then they.
Okay. So just imagine a piston. You know piston. You know the syringe, right? Syringe, you know? Syringe. Syringe is having a piston. Okay, just imagine the syringe one end you are closing with this arm. This thumb you are closing one end. And when you compress, when you push that piston, what happens? The air is getting compressed. Okay, so compression. So that is actually compression of air. When you remove the piston, what will happen? It will expand. We call it as rarefaction. Compressions and rarefactions. You studied in 9. That term was there in the textbook. Okay, now I'll explain. When you push it, what will happen, Zian? What will happen?
Compression.
When you push the piston, compression will happen. And when you remove that piston, expansion will happen. Same way, when you make a sound, the air particles in front of you will vibrate. It will compress. Okay, so when you're talking something, if you're talking through an air column, through a tube you're talking. So air particles near to your mouth will undergo compression. Here, there is no compression. Then again, compression. This is getting actually transferred. This energy will be transferred to the next set of air particles. So compressions, rare fractions, compression, rare fractions. That is how the sound is traveling. If I'm talking something, you can hear that by this method. Okay. You cannot see. Okay. So compression, rare fractions, like that it is getting transferred. Now, whenever you have a compression, you will represent like a positive going peak, rare fraction, negative going. Like this, you are actually representing like this. Okay, it's basically compressions and rare fractions. You can represent it as a wave. The compression part you will represent it as a positive going peak, and rare fraction you will represent it as a negative going. Okay, so we were talking about different types of waves. So waves is actually, it is method by which the energy is transferred within a medium without the actual transfer of matter. The air in front of my mouth is not moving. The air particles vibrate, it compress, expand. Then that energy is transferred to the next air column. That is how the sound is getting traveled. The sound is traveling. Okay, now there are basically three types of wave. The first type is mechanical wave. Then the second type is EM wave, electromagnetic wave. And the third type is matter wave. The mechanical wave is again divided into two classifications. That is longitudinal and transverse. Transverse wave and EM waves is classified into how many? Any idea? You studied in chemistry. How will you remember? RMI Lux G. You can remember like that. Radio wave, microwave, infrared, light, the visible light, ultraviolet, X-ray, gamma. You can make your own mnemonics, okay? Yeah. Okay. Huh? You can make your own mnemonics. This is my version. RMI Lux G. Okay, so radio micro, this see next year in grade 12, if the syllabus is not changing, 8th chapter is electromagnetic waves. The full chapter is about these waves. Only 3 pages. Small chapter. So anyway, this you should remember. RMI LXG, you should remember. All the 7. Okay. Now matter waves are the waves associated with L means visible light. Light. Okay. 400 to 700 nanometer frequency. Huh? What? Wavelength. What? Yes. എല്ലാം താഴെ പോവാന്ന് ഞാൻ കണ്ണും പിടിക്കത്തില്ല ഒന്നുമില്ല. Okay. Then matter waves. Matter waves are actually the waves associated with subatomic particles. You know Heisenberg's principle. What did he say?
You can't predict the position and momentum at the same time.
Why? Because the particle is continuously moving. Subatomic particles are continuously moving. If the subparticle particles are moving, there will be a wave associated with that. Okay, that wave we call it as matter wave. Okay, so these are the 3 types of waves. Okay, so give right, there are 3 types of waves. There are 3 types of waves. Write these names: mechanical, electromagnetic, matter. Okay, first part you write mechanical waves. First mechanical waves. Mechanical waves. Mechanical waves. These are the waves. Huh? These are mechanical wave. Below you write. These are the waves which need a medium for propagation. Mechanical wave. These are the waves which need a medium for propagation. Mechanical wave. These are the waves which need a medium for propagation. Which need a medium for propagation. They cannot travel in vacuum. They cannot travel or propagate through vacuum. They cannot propagate through vacuum. They cannot propagate through vacuum. Done?
No.
They cannot propagate through vacuum. Second type, EM waves. They are non-mechanical waves. EM waves, electromagnetic waves or EM waves. EM waves. They are non-mechanical waves. They are non-mechanical waves. They are non-mechanical waves which do not require a medium for propagation. They are non-mechanical waves which do not require a medium for propagation. They are non-mechanical waves which do not require a medium for propagation. There are 7 EM waves. And right, okay. There are 7 EM waves: radio, micro, infrared, visible light, ultraviolet, X-ray, gamma ray. There are 7 EM waves. There are 7 EM waves. Okay, done, right? Now you write matter wave, which is also known as de Broglie wave. De Broglie wave. Matter wave or de Broglie wave. Third one. Matter wave or de Broglie wave. You studied, right? De Broglie wavelength. What is it? Lambda is equal to H by P, right? MV, H by MV, momentum. Okay, matter wave or de Broglie wave. These are the waves associated with material particles. These are the waves associated with material particles. These are the waves associated with material particles. Example, electron, proton, etc. Example, electron, material particles. Example, electrons, protons, etc. They are associated with electron, proton, etc. Then, right? Now, in this chapter, this year in physics, we are studying only mechanical waves. Next year, chapter 8, full EM waves. De Broglie waves also coming in few chapters. So this year we have only mechanical wave to study. So give main heading mechanical wave. Below that subheading, below that, these are of two types. Mechanical wave is of two types. These are of two types. Mechanical wave is of two types. First one, transverse wave. Transverse wave. Okay, 9th grade you study transverse wave. What is transverse wave? What is transverse wave? Transverse wave. See, in case of a string, listen. In case of a stretched string,
I don't
tell.
say what the compressed and missing.
In case of a stretched string, how is the wave propagating? Like this. So,
Yeah.
the central line is the mean position. The particle move. This is the motion of the particle. This is how the motion of the particle, or the displacement of the particle is like this. And in which direction is the wave propagating? This direction. If the direction of propagation is perpendicular to the direction of displacement, this is the displacement. In case of a wave goes like this. So displacement, and this is how it propagates. Propagation and displacement is perpendicular to each other. Then that wave we call it as a transverse wave. Example, wave propagation through a string. It is transverse in nature. The string moves up and down. At the same time, the wave is propagating in a perpendicular direction to that. Okay. So this will be the motion of particle. So you write transverse wave. Below you write, if the direction of vibration of a particle is perpendicular to if the direction of vibration of a particle is perpendicular to direction of propagation, is perpendicular to the direction of propagation, then it is known as transverse wave. Then it is known as transverse wave. Example, wave in a stretched string. Draw the diagram also. Wave in a stretched string. Draw the diagram. Done?
Yeah.
Okay. Next is longitudinal wave.
This stuff, man.
Longitudinal wave. So as I told you in case of sound wave, the vibration is in this direction, propagation is also in the direction. The air particles are moving in this direction. Direction of propagation is also in this direction. So they both are in the same direction. That is longitudinal. So right, longitudinal wave is the direction of vibration of a particle is the direction of vibration of a particle is parallel to the direction of propagation of wave is parallel to the direction of propagation of wave if the direction of vibration of particle is parallel to the direction of propagation of wave, then it is known as longitudinal wave. Then it is known as longitudinal wave. Example, sound wave. Okay, got it, right? Okay, so these are the two types of mechanical wave. Okay, these are the two types of mechanical wave. Now, in your textbook, the next topic is given as displacement in a progressive wave. So, I will just tell you what is a progressive wave. As the name suggests, a wave which is moving, that is a progressive wave. Okay. A normal name for any wave, it is progressive, which is progressive in nature. If it is moving from one point to another, it is known as a progressive wave. Understood? Initially, you will study wave, then you will study transverse wave and longitudinal wave. And after that, the next topic is displacement of a progressive wave. So first you should know what is progressive wave. Progressive wave means any wave which is propagation. We call it as progressive wave. So write progressive wave. The waves travel. That is not the third part. Just give it as a side heading, progressive wave. Progressive wave. The wave traveling from one part of the medium to another. The wave traveling from one part of the medium to another. The wave traveling from one part of the medium to another are called a traveling or progressive wave. The wave traveling from one part of the medium to another are called traveling or progressive wave. Okay, got it right? Now give heading. Displacement equation of a progressive wave. Displacement equation of a progressive wave. Displacement equation of a progressive wave. Royden, tell me what's the equation for SHM? SHM equation, displacement equation of SHM. Royden.
Cos omega t plus 5.
Yeah. Zian, displacement equation for SHM.
It is 74. A plus. No.
Hmm.
A cos.
Hmm.
Omega t plus.
Hmm.
5.
I am right?
Yeah.
10 times.
What did I do?
You didn't do?
I didn't change signal.
Okay. Hmm. Steve.
Yeah.
Displacement equation of SHM.
Cos omega t plus 10.
Agash. Displacement equation of SHM. You didn't hear anything? Eh? 10 times. Displacement equation of SHM. X is equal to A cos omega t plus 5. Okay. Displacement equation of a progressive wave. So now displacement equation of a progressive wave. Listen, I'll write the equation y x comma t. Y x comma t, because y means y is the representation for displacement. Okay, it changes with x and time. The variable x and time t, that is the meaning. Okay, and the equation is a, don't write it now. Okay, a sine kx minus omega t plus 5. What could be a? Amplitude. Then what do you mean by amplitude? What do you mean by amplitude? What is amplitude? Definition.
Just magnitude of displacement.
Amplitude is the maximum displacement.
Maximum.
What is K? Is K is wave number. You studied in chemistry. Wave number. Now, omega is what? Angular frequency or velocity. What is phi? Phase constant. Phase constant. Phase. X and t are the variables. Okay, so this is the equation. You write the equation. No, don't write. This is the equation if the wave is along positive x-axis direction. Don't write now. If the wave is along positive x-axis, that means if the wave is propagating like this. If the wave is propagating towards negative x-axis, it can go from 0 towards negative direction or positive direction. If it is towards positive direction, it is kx minus omega t. Okay, if it is along negative x-axis direction, formula is x comma t a sine kx plus omega t plus 5. Understood? Okay, if the wave is propagating along negative direction, this is equation. If the wave is propagating along positive direction, this is the equation. Is that clear? No, this is like that. If it is positive x-axis, we should put negative. If it is negative x-axis, it will be positive.
You told it.
Oh, this is what I wrote is correct. Let me check. Positive x-axis, negative x, and negative x-axis positive. Yeah, this is actual thing. Understood, right? But write one sentence, then you can write the equation, right? To represent a traveling wave, to represent a traveling wave, to represent a traveling wave, to represent a traveling wave as a function of position and time. To represent a traveling wave to represent a traveling wave as a function of position x and time t. X is the position. To represent a traveling wave as a function of position x and time t, hyphen you write, next line you write. A traveling wave in positive x-axis is given by, and a traveling wave in positive x-axis is given by, write this equation, and negative x-axis, write this equation. Okay, fine. What equation? Did you write what all things? A is amplitude and not? Okay. A is amplitude, C is wave number, omega is angular frequency, phi is phase constant. All of you wrote that, right? Okay. Now, next term you write. Okay, that equation is done, right? Now, first term, amplitude. You're going to write all the definitions, okay? Amplitude. You write by yourself, you know what is amplitude. What is amplitude? What is amplitude? It is a maximum displacement of a vibrating particle from its mean position. Amplitude is the maximum displacement of a vibrating particle amplitude is the maximum displacement of a vibrating particle from its mean position. Okay. Second name, angular frequency omega. Omega. Omega is what?
Yes.
Omega is equal to 2 pi f or 2 pi by t. Write the equation. Omega equal to 2 pi f or 2 pi by t. See, actually that eighth question. The question is when a couple is acting on a rigid body. That is the question. That is, what's the answer? When a couple is acting on a rigid body, what do you think? What is the answer? A couple is acting on a rigid body. You know, remember in couple, system of particle. A couple is acting on a rigid body. I'll tell you the option. A body is in, then the body is in a body is acting on a couple is acting on a rigid body, then the body is having translational but not rotational.
Couple is for rotation.
Couple is for rotation. So that option is wrong. Translational as well as rotation. No. Neither translational nor rotational. No. Body is in rotation but not translation.
Yeah.
That is supposed to be the answer. You check with.
Ask them, ask me.
You keep yours, Jessica. You keep yours with yourself. Okay. Keep it with you. Okay. Huh?
Okay, I have
So you check with other, like all the papers is being corrected by one teacher. You are all corrected by one teacher. I have asked. Let him reply. I'll check the equation answer. Jana, when you wrote rotation, they got it wrong. Everyone got it wrong. As of now. I don't find any. I don't. I will check the guides also. If anything is there, I don't think anything else is there. A rigid body or in couple means it has only rotation, no translation. Anyway, we will see. Okay. So angular frequency is not done, right?
Yeah.
Now next wave number. Wave number. Next term is wave number. Wave number is K. You studied in chemistry. What is the formula for wave number?
1 by lambda.
1 by lambda you studied?
No, 1 by
1 by nu. 1 by nu. Okay, here you write 2 pi by lambda. K is equal to 2 pi by lambda. You will check the other way. Huh? So K is wave number is K, which is equal to 2 pi by lambda. You write the formula. K is equal to 2 pi by lambda. Now listen. In chemistry, what you studied 1 by frequency, right? Huh? Frequency is basically what? Huh? 1 by T. Or in terms of lambda, I'm asking.
C by C by
No, in the equation C is also not there. Okay, so leave. Anyway, K is 2 pi by lambda. You write K is equal to 2 pi by lambda.
Ma'am, wave number is 1 by lambda only, right?
Wave number is?
1 by lambda only, right?
No, 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 no.
In
2 pi.
chemistry, I think so we learned that.
In
1 by nu.
Okay, okay. Then that is only applicable for chemistry. Here it is 2 pi by lambda. Okay. Finished, right? Finished? Finished. Now, next term. Listen, next term, I will explain first. Phase of a wave. Phase of a wave. See, this year it is not important, but next year, one full chapter, you should know this concept. I will tell you phase of a wave. See, sine wave and cos wave, how do they differ? By how much angle they differ? Can you tell me? What is the difference between sine wave and cos wave in terms of angle? This is sine wave. This is cos wave. Any idea how much they differ in angle? Cos 0 is 1. When will be sine 0? Sine 1, when sine 90 is 1. So cos is 1 at 0 degree. and sine is 190 degree. So there is a difference of 90. So phase difference between sine and cos is 90 degree. Understood? Cos, so that is sine and cos, you will understand it easily. But if some new wave is given to you, it will be difficult to identify. But that is phase difference. Okay, now two sine waves are always in phase. This is one sine wave. This is another sine wave. These two waves are in phase. That means whenever the first wave is zero, the second wave is also zero. Whenever the first wave is maximum, second wave is also maximum. Okay, they are in phase. Okay, so that is in phase. So just write phase. It describes phase of a wave. That is the heading. Below that you can write. It describes
What's the heading?
phase of a wave. Phase. PHASE. Okay. Phase.
What is this?
Phase of a wave. It describes the state of motion. It describes the state of motion. It describes state of motion as the wave propagates. It describes the state of motion as the wave propagates. Done? Finished, right? Now, all of you take your textbook. Do this second example, 14.2 or 15.2. Anybody without textbook?
Yes.
Second example, okay? You have? John, you have? No need to write the question, just the answer. This is you have? Other
Sometimes yeah, something wrong with it. Bro, but you will also find I thought we had a more bonds. Okay, I want to work to. That's all.
Yeah.
Yeah, I don't have money. Yeah, my mom did most of this. I don't want to. Bro,
Sir,
No, ma'am.
Pranav finished? Pranav finished.
Yeah.
Finished? So the equation was given. What is the equation read? Y is equal to?
Yeah.
Y is equal to? What's the equation?
X comma t is equal to 0.005
0.005 sine
30x minus 3t.
30x minus
3t.
3t. That's it.
Yeah.
Okay, so here phi is not given, so take phi as 0. Okay. Huh? What? 3t or 8t?
80x minus 3t.
80.
But print is
This is 80x.
it's so fair.
കന്നഡയുടെ power നോക്കുമ്പോ
I understand it's easy.
correct. You got it from
I got no
no.
yeah,
Yeah.
That's all.
Omega is 2 pi f.
Yeah.
Huh.
No, it's given the question.
Okay, so what is the amplitude? Amplitude is how much? 0.005, right?
5/3.
Meter. Unit you should write.
2/3. 5/4.
Then wavelength is how much? K is 80, right?
Three.
So how will you find wavelength? K is equal to 2 pi by lambda, or lambda is equal to 2 pi by K. So 2 pi by 80, right?
5/40.
Pi by 40.
Plus 5/6.
What is the unit? 2 pi is radian, wavelength is meter, so radian per meter. That is K.
Okay.
Oh, they asked wavelength. Sorry.
Question.
So then it is meter. Then time period is what? Omega is given as 3 is equal to 2 pi by t. So t is equal to 2 pi by 3 seconds.
Yeah.
Frequency is E by 2 by.
The period of frequency of the wave frequency is what? Huh. Frequency is 3 by 2 pi hertz. Now, calculate displacement for x is equal to 30 and t is equal to 20. So just simplify and keep, okay? You cannot find the sign value and all. We don't know what's the value of that sign. So you just put x is equal to 30 and t is equal to 15 and simplify and keep. You will get 24. You'll get sign 24. That's it, right? See, they are asking us to find the value of y is equal to 0.005 sine. What is x value given? 30. What is t given? 20. This is what is given. Sure.
First I converted to.
30 centimeter,
Yeah, so-
0.3, right?
Yeah.
This 24 minus 60. Correct, right? Correct? Keep it like that. That is enough. That much is enough. We cannot simplify that. Okay. Okay. So you understood the basic equation, everything. Now we are going to find the speed. This is okay, right?
Yeah.
Huh? Huh.
You're not.
Now, next, speed of a traveling wave. See, for speed of traveling wave, I'm not giving you the derivation. When the teacher is teaching, if teacher takes that time, you tell me. So please not doing derivation. You have to check whether the teacher teaches the derivation or not. Now, the next topic, speed of traveling wave. Three equations are there: speed of traveling wave, transverse wave, and longitudinal wave. Transverse and longitudinal I will teach. That normally they will take. For traveling wave, C is equal to F lambda. For that, we already studied in 10th grade. So the derivation no one used to take. So if they take, that time we will see. I will give the heading, speed of traveling wave. Speed of traveling wave. Just write the equation V is equal to nu lambda. That is enough. V is equal to nu lambda. V is equal to nu lambda. Just equation is enough. We'll do a problem. We'll do a problem, okay? After that, we will do the other two equations. Write the problem. Finished? Thanks. If a progressive wave traveling in positive x direction
Traveling in
positive x direction if a progressive wave traveling in positive x direction having amplitude of 6 centimeter frequency 200 hertz. Your question? What happened?
no.
If a progressive wave traveling in positive x direction, if a progressive wave traveling in positive x direction, having an amplitude of 6 centimeter, frequency 200 hertz, and velocity 400 meter per second, then write the equation. Then amplitude 6 centimeter, frequency 200 hertz, velocity 400 meter per second. Then write the equation of that progressive wave. Okay? Can you try? You know the standard equation. First you write the standard equation and then put. Do.
Ma'am, can you repeat the question?
If the Sandra, I will send.
Commission amplitude on the side.
Huh?
Amplitude.
Amplitude 6 centimeter. Yeah, Sandra, I sent you. Yes. Yeah. And here.
Case 5. 5. No, first question. Right questions. Fast.
Yeah, if face is not given, you can take it as 0. If face is not given, 5 is not given, you can take it as 0. Face.
Oh,
What's the equation?
6 sin pi x minus 400 pi.
Again.
6 sin pi x minus 400 pi t.
6 sign.
No, 6.
Yeah.
Amplitude 6.
okay.
Centimeter.
Oh, 6 into 10 raised to
0.06 you write. Don't write 6 into 10 raised to and all in the equation. It should be 0.06.
yeah 0.06.
Agassi explain cheyna. Engane equation kittiyenu.
Pi x minus
Eh?
400.
അത് അപ്പൊ അവൻ പറയണ കേട്ട് അങ്ങനെ എഴുതുമല്ലേ?
അല്ല ഈ നമ്മൾ ഫിക്സ് അല്ല അപ്പൊ മാറ്റി.
That's omega.
സ്റ്റീവ് ബാക്കി എല്ലാത്തിനും എങ്ങനെ ഉണ്ട് മാർക്ക്? കെമിസ്ട്രി 20. മാത്സ് പിന്നെ എന്താ? ഇംഗ്ലീഷ്, കമ്പ്യൂട്ടർ 18. Physics 19. Teachers എന്തോ MCQ ആണല്ലോ 4 marks MCQ ലാ പോയി. Aradhana, how about your other subjects marks this time?
Ma'am, I got physics and chemistry all, no, physics I got 24, biology and chemistry it was 27, and English also 27.
No, I cannot hear you.
Oh, ma'am, I got good marks in all the other subjects also.
Chemistry bio 27.
Yeah, ma'am.
Max, you have max?
Yeah, ma'am, I have math.
How much?
That was less, ma'am.
Use that, use it for electric.
Ma'am, the timing was very less for both physics and physics and math, ma'am. Teachers in other classes they gave extra time. For us, it was very less.
How
So
much you got, Max?
21.
What is
Okay, English?
27, ma'am.
0.06? She asked for equation, ma'am.
Okay. So, did you get the equation?
Yeah, 0.06
Did you get the equation?
0.06 sine pi x minus 400 pi.
Okay, so we'll do.
Centimeters.
So amplitude is 6 centimeter, right? So it will be 0.06. Anyone fail for physics?
In my class.
Huh? Voice section. Okay. Then frequency 200 hertz, right? So in the standard formula, we need A sine. What was the formula? Kx minus omega t. So you have to find the k. How will you find k? K is equal to 2 pi by lambda. Is lambda given? No.
No, we have to find it.
How will you find lambda?
Lambda?
V is equal to nu lambda. What is V? What is V?
B, the 400.
What is nu?
New is 200.
So 2 is the wave number. Okay. Y is equal to 0.06. 2x minus what is omega?
No, it's not 2, it's not 2, that's lambda value. We have to find 2 pi by lambda.
Ah.
Yeah, it's k equal to 2 pi by lambda.
Okay, pi, right? Pi. K is 2 pi by 2.
You got an extra 100.
What is omega?
Omega. Omega.
400 by
400.
400.
That's level.
Okay, so this will be the equation. All of you got the equation, right? This is the equation.
0.0 sine.
Huh?
Yes, sine.
What sign?
0.06.
Ah, yeah, sign. And this much meter, you have to write meter. Why write that much meter? Unit matters. Did you lose mark for not writing units?
No,
You lost.
I forgot the units.
Unit, equations, everything. Someone is drawing stress strain graph like an art without what is x-axis, what is y-axis.
It's a bet, okay?
Okay. Finish, right? Is it okay? Finish? Okay. Now we have two small derivations to do. Right.
Ma'am, can you
Yes,
move?
yes. Yes, Andra.
Can you move?
Ah, okay.
How is it by the way? How is it?
Finished? Okay. Sandra, finished, right, Sandra?
Yes, ma'am.
Okay. Now, two more derivations. After that, half of the chapter will be over. In one more class, if you want, we can finish, but we will slowly go. Two more classes to finish this chapter. Huh? Morning I'll take. Tuesday morning I'll take, okay?
When?
Tuesday morning,
Yeah, when is it?
8.
8.
Why? What happened?
About 9.
Huh?
About 9.
No problem. What happened? 9 to 10:30, other batch from 10:45, 11. No problem.
Yeah.
No, 8 is fine.
No, 9.
Why you want 8?
Then I won't feel hungry. No, finish this earlier. So otherwise, listen, if I have to come at 9, I have to wake up at 8.
Ah,
Either way.
ah.
So if you're gonna come at 8.
So bring your food.
We all are either wanna wake up at 7. Every day we had school.
Ah.
So for the first week, either ways we all wake up at 7. We will. We will come to school and they come up to the exam on time. We are just going. We gotta join online, right? That's right. Yeah, that's right.
Who?
She's not from online, that's what I'm saying.
Okay, next we have two small derivations, speed of transfer. So next week, Tuesday, we have test also.
Nine also.
Yeah, oscillations chapter. Yeah,
Christmas.
yeah, Christmas. Yeah, after that, we can, now you study. After that, full day Christmas. Yeah, study. Okay. So, speed of, no online, no, speed of transverse wave. Two derivations, okay. Normally they take this derivations in school. Speed of transverse wave and speed of longitudinal wave. 2 mark they might ask. Write the question. So speed of a transverse wave, or they will ask you speed of a stretched string. Wave on a stretched string. Stretched string means it's a transverse wave. You should remember. Okay. So right. The speed of a transverse wave depends on speed of a transverse wave depends on tension on the string, tension on the string T, capital T, okay, tension on the string T, and mass density. Mass density. In bracket, you have to write what is mass density. Any idea what is mass density? Normal density is mass by volume. Mass density means mass per unit length. Okay. Mass per unit length. And the symbol you use is mu. Write that also. Zian എഴുതുന്നുണ്ടോ? Mass per unit length, mu. Done? Okay. Now this derivation we will do using dimension analysis method. Remembering dimension analysis?
Yeah.
Okay. So write the dimensional formula of T. What is T dimensional formula? Tension is same as force, right?
MLT ratio is 2.
Ah.
Time.
So tension is,
Time.
which is same as force.
MLT is 9.
Force is ml
T
T raised to minus 2. Now mu is what? Mass per unit length, right? Mass by length.
M by
ml minus 1. Correct? Yes or no? Do 2 by 1. Shh. Hello? Do 2 by 1. 2 by 1. Listen, I will do, then you can copy. 2 by 1. If you do 2 by 1, ml minus 1 divided by ml t minus 2. mm cut. L goes up because L minus 2 t square, correct?
Yeah.
Okay. This one I can write it as 1 by L square t minus 2, agreed? Minus 2, it goes, denominator becomes like this, correct? This one I can write it as 1 by L t minus 1, the whole square. Correct? LT minus 1 is velocity. That is what we need. We need velocity. Velocity in terms of tension and mu is what you need. So this is what? 1 by V square. Now you will get mu by T is equal to 1 by V square, or V square is equal to then T by mu. V is equal to root of T by mu. That is the derivation. Easy, right? Similarly, for longitudinal also we have.
So is important.
It is there in the textbook. If teacher is teaching, then you have to study.
English learning. You're not here yet.
So next week we will finish this chapter, then we will start revision for your upcoming exam. You have exams coming, right? After 2-3 weeks, school. You have PT3 something.
No, annual.
Only annual. Anyway, then a revision is required. And
We can take 1/2 and 2/2. 2/1.
in textbook it is given 2/1. That's
1/2.
in textbook 1/2.
Yeah, it's opposite way.
Opposite is given. You can do both ways.
Both the same.
Both are same. You will get the same thing. Are you sure 1/2? Then why I did like this?
2/1 in maths you do it.
Because L2 T raised to minus 2.
No, maths you do it 2/1.
അല്ല
ഇത് mu മുകളിൽ എഴുതി കഴിഞ്ഞാൽ ശരിയാവും. Both are same.
L square T raised to minus 2 അവിടെ L raised to minus 2 T square.
ML minus 2. Both are correct. Both way you can do it. I thought in text. I was not checking textbook. I used my old notebook. Finish? All of you finished? Then last, do by yourself. Okay, I will give you the what to be done, then you will do by yourself.
Why?
Now you will do speed of longitudinal wave. Speed of longitude. This is transverse wave speed, right? Next is speed of longitudinal wave. Yeah, Jessica. Yeah. Speed of longitudinal wave. Right. Here the velocity is expressed in terms of. Here the velocity is expressed in terms of. Here the velocity is expressed in terms of density and bulk modulus. Density rho and bulk modulus B. Here the velocity. The speed of longitudinal wave is the heading. Okay. Here the speed or velocity, whatever it is. Here the velocity depends on density and bulk modulus. What is density? Mass by volume. What will be the dimensional formula? Zian. What will be the dimensional formula for density?
ML raised to minus 3.
Yeah, ml minus 3. Ayman, what will be the dimensional formula for bulk modulus? What is bulk modulus? Bulk means it is volume. Modulus, volume stress by volume strain. Bulk stress by bulk strain. Okay, so it is basically you can write it as stress by strain, right? What is the dimensional formula of strain?
Strain in this.
No dimension. Remember it. Change in length by original. Okay, so no dimension. What's the dimensional formula of stress?
Stress is a pressure.
Force by area. It is pressure itself. Remember it. So force by area, what will be that?
ml minus 1 T raised to minus 2.
ml minus 1 T minus 2, right? Okay, now you do 1/2 or 2/1. Anything is fine. 2/1 is done in textbook. Okay, then do 2/1. I was actually doing 1/2. Okay. 2/1, if you do it is easy. The other one also you can do 1/2 or 2/1. Okay, it doesn't make any difference. L square T minus 1 minus 2, what you can write? L T minus 1 the whole square. That is V square. So V will be equal to, therefore, B by rho is equal to V square, or V is equal to root of B by rho. Easy, right? Easy derivation, right? B by rho, B by rho. Easy, right? Sandra, what is Sandra?
Yes.
Aradhana, is it okay?
Yes, ma'am.
Okay. So, study oscillations thoroughly. I will tell you the sure questions.
Only questions? The only question.
I will tell you the questions which surely will I will ask.
The only question.
Not the only questions. These questions will be asked. First question, velocity of a system, acceleration of a system, two derivations. Simple. Velocity of a system will be asked. Acceleration of a system will be asked. Simple pendulum derivation will be asked. The last one, 2 pi root of L by H. Simple pendulum, last derivation which we did, right? These three derivations, sure. Velocity in a system, acceleration in the system, simple pendulum derivation. These three derivations, pakka I will ask. These three, surely it will come. So maybe 3 plus 2 plus 7 marks from this.
Can you repeat that?
Yeah, yes, Sandra?
Can you repeat that?
Oh.
Yeah, you have done.
Velocity in a system, acceleration in a system, simple pendulum. This much 7. 3 plus 2 plus 2, 7. Total maybe 15 or something. 15 or 20. 20. So, this 7 all should get. Okay, then don't study just this, okay. Study problems also. Problem also I will tell. Yeah. That after SHM we did some word problems. Those problems. Study. Only small chapter it is actually. Okay then.
Thank you, ma'am.
Bye bye. Bye Aradhana. Bye Sandra.
Thank you, ma'am. Bye.
Bye bye. Bye.
Bye.